Okay, so here in 3.1 and in all of chapter 3 really, we're going to talk about solving systems. Now what that means is instead of just having one equation that we're going to solve for two or three coming up. But you're talking about having two variables, so here we've got a y and we've got an x, and two equations. When we get to the ones that have three, then we'll have three equations and three variables. Now here in 3.1 we're going to solve by graphing, and then we'll solve by some other methods coming up. This one takes a minute or two, but it is pretty simple. You already know everything you need to know. Okay, so here's what I'm going to do. I'm going to go through and just graph each of these. So I'm going to put this one in blue. This is in y equals mx plus b form. So I'm going to start at my y-intercept of 2, and I've got a slope of 3. 1, 2, 3 over 1. You are going to want to have your graph go all the way across the page, and you are going to want to have a good picture. I would recommend graph paper or coordinate grids of some sort, not probably just sketching it on notebook paper, because you do need a precise graph. Okay, and then same thing with this one. So this is in y equals mx plus b form, y-intercept of 4, slope of 1. Okay, now what we're looking for is the x and the y value that these two lines have in common. That's true for both of them, which basically means where they cross. Here is my answer. So that's the point 1, 5. Now you'll see your x value is 1, your y value is 5. Now that's the main idea of solving by graphing. We're going to look at a couple of others that are a little bit more messy, and then we're going to look at our weird situation. So here's our next one. Now you'll see that these are not in y equals mx plus b form. So that's the first thing I'm going to do. I'm going to put this first one in blue, and I'm going to go through and I'm going to get this in y equals mx plus b form. So I'm going to move my x over, and I'm going to divide by my 2. So y equals negative 1/2 x minus 3.5. So graphing this thing, my y-intercept is at negative 3.5, and I have a slope of negative 1/2, which means I'm going to go down 1 over 2. Down 1 over 2. You'll get the idea. Okay, so here is my line. And I'm going to do the same thing with my other problem. So I'm going to put this one in red. So I'm going to move my 2x over. And divide by my negative 3. So y equals 2/3 x plus 0. You don't really have to put that plus 0 there, but I did. Okay, and then slope, rise over run. So 2 and over 3. Okay, now I'm going to keep going. Down 2, back 3. Now that's my important point. Down 2, back 3. So they cross right there at negative 3, negative 2. So that's my x, that's my y. So these take a minute to do, but really you've done everything that's in them before. Okay, now I want us to look at kind of a tricky situation. because this one's going to be a little bit different. You don't know by looking at it yet, but this is one of our weird situations. So I'm going to do the exact same thing. I'm going to get these in y equals mx plus b form. So bring my x over, divide by my -3, and this should be a y. I don't know why I put an x there. So y equals 1/3 x minus 2/3. So let me graph this thing in -2/3 up 1 over 3, up 1 over 3. Okay, so here's my blue line. Okay, and then same as the other ones, I'll put this second one in red. So I'm going to do the same thing, move my 4x over. And divide by my -12. So I have y equals 1/3 x minus, when I reduce this, 2/3. Now I want you to notice this. If you look at these, look at those two lines. They're exactly the same, which means when I go to graph this red line, it's going to be lying right on top of the blue line. So basically, they have every point on that line in common. Here's how you're going to write that, because you don't just have one answer anymore. You've got an infinite number of answers, every point that lies on this line anywhere in here. So here's how you're going to write that. Now this is a notation you probably have not seen before. Any x and y such that, that's what this line means, such that, and then I'm going to put my equation here. Y equals 1/3 x minus 2/3. So we're saying any x and y value as long as they're on that line. Now I don't know why someone chose this as a notation, but you'll see this notation a lot. So accept it, because you're going to see it a lot. Now, your answer here is not all real numbers. Sometimes people like to put all real numbers because it's everything on that line, but say that's not an answer. It's only the stuff on the line, so you really do need to specify what your answer is. Okay, and here's our last one. Also, kind of weird situation. Let's do the same thing. You wouldn't know that it's a weird situation until you get into the problem. Okay, so I'm going to get this in y equals mx plus b form. So I'm going to move my 2x over and divide by the 4. So y equals 1/2 x plus 3 over 2, which I'm going to write as 1 and 1/2. Okay, so up 1 over 2. So I graphed this kind of quickly. We should be pretty good at graphing these by now, so hopefully you're good to go with this. Alright, so there's that line. And then I'm going to put my second one in red. Now, this one is almost in y equals mx plus b form. Just need to divide. So I have y equals 1/2 x minus 2. Now I want you to look at these two equations. They're not the same line this time because their y-intercepts are different. Here's my y-intercept. Let me go ahead and graph this one. I want y'all to think about this. Think about what kind of lines these are. I haven't drawn them perfectly because I'm kind of freehanding it here. But if it has same slope, different y-intercept, those are parallel lines, which means they are never going to cross. If they never cross, your answer is no solution. You don't have one. Or empty set. Alright, so this is our graphing linear equations with the systems. We are going to solve by some other methods in 3.2.